promoting a healthy environment. It's the air we breathe. Clean, safe water. Responsible management of our natural resources. We protect and restore for a sustainable future. Environment matters.
We've been working on this watershed for a long time, but this is the keystone. This is the piece that had to happen.
A state-of-the-art water treatment plant now coming online is bringing a stream poisoned by acid mine drainage for nearly a quarter of a century back from the dead. Plus,
this is the most extreme conditions this equipment has ever been used in, but it's working really well.
A demonstration project in southern West Virginia is looking to convert reclaimed surface mines into fertile, productive farmland. Hello everyone, and welcome to another edition of Environment Matters. I'm Jake Glantz. In 1994 and again in 1995, water trapped underground inside the TNT mine in Preston County blew out the hillside above Muddy Creek, sending millions of gallons of untreated acid mine drainage into the stream and the Cheat River beyond, killing fish for 16 miles downstream and leaving Muddy Creek a lifeless orange ditch. TNT declared bankruptcy in 1995, and the DEP has been treating the discharge ever since. Now a new treatment plant is the final piece in the decades-long process to restore the lower Cheat watershed. The DEP's Mike Huff has the details.
The water leaving the new Muddy Creek treatment plant near Albright is clean and clear. It's a day that's been a long time coming.
This is a huge deal. TNT was the site that really brought Friends of the Cheat together. The blowout in 94 and then again in 95 was the wake-up call to this community. So to be standing here 25-ish years later is just amazing. I mean, frankly, I've been a little emotional just standing on the sideline, looking around at people that have been involved since day one, and this is a reality. I mean, we are standing on the bank of Muddy Creek talking about trout. I mean, never would have thought that was possible, so it's a huge deal.
The lower 3.5 miles of Muddy Creek were in declining health even before the mine blowouts of the 90s, thanks to acid mine drainage coming from higher up in the watershed, here at Martin Creek and farther upstream from Ficky Run.
Above that confluence, Muddy Creek's a trout fishery, a healthy stream, cold water temps, trout that survive year-round. So we really have this small little stretch to connect to the greater Cheat, and we have a lot of good populations of macroinvertebrates to help repopulate. So, you know, we don't want to make any promises that are too big, but in a couple years, you know, I think we'll see bugs coming back very soon and fish not too long after that.
The DEP hosted a tour of the $8.5 million facility recently. The plant treats water from 4 different acid mine drainage sources in the watershed. Incoming water is mixed with a slurry of lime and polymers. That raises the pH to neutralize the acid and causes the metals, iron, aluminum, and manganese, to settle out in these 2 80-foot diameter clarifiers. The resulting sludge is pumped back into the mine or into a series of geotubes for later processing. The plant can fully treat 4,200 gallons per minute. In extreme flow events, it's capable of hydraulically passing up to 8,000 gallons a minute while still adjusting the pH to neutralize the acidity.
It is conveyed through pipelines and manholes, and we gravity flow it down here to the new plant location. And across on Route 26 here, we also put in new mine seals on the Ruth Bell Preston Energy Mine complex that previously had never been treated before. So it's about equal flow that matches our TNT mine. And it is also plumbed underneath of Route 26 and gravity flows into the treatment facility. And then upstream to the north of us on Route 26, we have approximately 7,000 feet of force main with 10-inch HDP buried line and a 1,300 gallon per minute pump station. So we're pumping the water from 2 other sources on our Ficky Run and our Viking Coal Company forfeiture site.
Ficky Run is arguably the most acid-impacted stream in all of West Virginia. Mining in the watershed dates all the way back to the 1800s, and many of the mines were abandoned prior to 1977, when a law was passed requiring mine operators to reclaim the sites once operations ceased.
Ficky Run was the real deal killer there, and quite frankly, the lion's share of all our pollution in the watershed. So we knew we needed to address the Ficky Run area in order to really restore Lower Muddy Creek. And that all came in. When we saw that we needed to address that, we decided, well, you know, this plant can do a little bit more. We can bring Ficky Run in, but we can also bring in a couple of other major bond forfeitures, you know, just by simple, you know, plumbing into these water sources and bringing pipelines down to this major plant. And by pooling all of that acid mine drainage out of these headwater areas in this watershed and consolidating them here in one large plant, just makes that much more sense economically and environmentally to treat it, you know, to deal with it that way. So that's the approach we really took, and that, you know, that's what we think will give us that restorable 3.4 miles of Lower Muddy Creek back to its original condition.
And that's where natural gas producer Southwestern Energy comes into the picture. Southwestern provided a significant part of the funding to build the pipelines that lead to the plant. Southwestern is also contributing to the operation and maintenance costs of the plant. It's part of the company's Freshwater Neutral initiative. The Muddy Creek facility is DEP's most ambitious acid mine drainage treatment project. And even though it's only been online for a short time, it's already showing results.
And to see, you know, this Muddy Creek come back, and ultimately the main stem of the Cheat Canyon, it's huge for me. I think it's a really, really cool project. It's going to be really great for the economics of the area. I think the recreation industry could potentially thrive again if we see significant improvements in water quality, and, you know, it's really, really a huge project for water quality in Appalachia.
After the pollution blowouts on TNT, the local community and the paddling community rallied and formed that, you know, a unique partnership with agencies and private business that we call the River of Promise. And the River of Promise was focused on the Cheat. The Cheat was the River of Promise. And now working up into Muddy Creek, again, is just something that I don't think that original group even thought was feasible. So to see those people still engaged and being here today, and then what is to come, I think should inspire other groups to stick with it, patience, persistence, and thinking outside of the box. We don't have endless resources, so we have to use the ones we have wisely and partner and work together, and that's how we've come this far, is cooperation and collaboration, and big props to, you know, the folks that had that vision in the beginning to let us carry it through.
In Preston County, I'm Mike Huff for Environment Matters.
The DEP has also installed an in-stream treatment facility on Glade Run, an acid mine drainage impacted tributary of Martin Creek. When that comes online in October of this year, the restoration work on Muddy Creek will be complete. The DEP's Watershed Improvement Branch recently awarded nearly $100,000 in grant funding for watershed groups across the state. The grants, ranging from $5,000 to more than $20,000, will go toward things like volunteer monitoring, capacity building, targeted water quality analysis, fisheries, and benthic studies in priority areas, as well as outreach and education. The grants support short-term projects, typically 2 years, with a focus on non-point source pollution. A list of this year's grant recipients is available on our website, dep.wv.gov. As we've seen earlier in the program, treating acid mine drainage in West Virginia is an ongoing and expensive problem, but a new process developed by researchers at WVU may have found a way to turn that liability into an asset. The DEP's Brianna Hickman joins us now with the details.
Jake, as we've shown you, the process of treating acid mine drainage leaves behind a sludge of metals, iron, aluminum, and manganese mostly, a waste product that had no value. Until now. In a lab on the campus of West Virginia University, 100 tiny machines quietly spin a liquid mixture. They're separating a specific group of minerals, rare earth elements they're called, from a solution derived from acid mine drainage sludge. Despite their name, rare earths like scandium, yttrium, and the lanthanides, elements 57 to 71 on the periodic table, are widely distributed in the rocks of the earth, just rarely concentrated enough to get a commercially viable deposit. Right now, most of the world's supply is controlled by China, but that could change.
I'm really optimistic about this. And no one ever accuses me of being a reflexive optimist, but this, I think, is one of the more exciting projects I've worked on in my career here.
Dr. Paul Zimkevich is director of the Water Research Institute at WVU. His team developed the process and is currently working to determine how to expand it to an industrial scale. The project is funded by the Department of Energy, which was looking for new ways to extract and refine the valuable materials.
It's just almost a matter of serendipity, but when US DOE first came out with the original solicitation for looking at coal-based rare earth streams, they really didn't have acid mine drainage in mind. They were thinking more like coal ash and coal refuse, partings, that sort of thing. But I just so happened to have an old data set from 1999 from a friend of mine in USGS. I decided to check out that old data set and found that there were lots of rare earths coming in to the AMD treatment plants and none going out. And that can only mean one thing: all of those rare earths were winding up into sludge, along with all the other metals. And it takes them out in a form that's really, like I say, easy to recover. All you have to do is acidify. You don't have to grind the stuff up. It's already in very finely divided form. You don't have to break it out of a mineral matrix, which is a big cost if you're mining this stuff. And the other thing that's really attractive about this source is that the mixture of heavy and critical rare earth elements versus the light ones, which are less valuable, is really favorable. So if you add up the critical and heavy rare earth elements against the total rare earth elements in AMD sludge, it's something like 60%. The last operating rare earth mine in the United States, in Mountain Pass, California, had only something like 12% heavy rare earths in it. The rest of it were lights.
The DEP is providing the team with its feedstock, sludge from the nearby Omega Mine treatment plant.
And it just so happens that that particular sludge, something like 17% of the rare earths in that sludge are an element called scandium. Scandium is by far the most valuable of all the rare earth elements. And it's worth something, it's an oxide, it's worth $4,500 per kilogram. That's a lot of money. It's the richest source of scandium we've come across so far. And DEP is treating this water, and they're separating out the sludge by running the effluent from their treatment plant into these things called geotubes, which are these big long sacs that naturally dewater, leaving these sacs full of sludge behind. Each one of those sacs is worth something like $20,000 in rare earth value alone, and they've got something like 18 or 20 of them out there at the Omega site right now. So it gives you some idea the kind of potential value that could be realized if this does turn into an industry.
Treating acid mine drainage is expensive. Besides the cost of building the treatment facility, the operations and maintenance costs to run a facility like Omega run into the tens of thousands of dollars annually.
Sludge management is a huge expense for when you're treating acid mine drainage. So if we can find a beneficial use of this byproduct of the treatment process, it would be a tremendous savings to the state.
I've spent most of my career working on acid mine drainage problems in West Virginia, and we're still working on mines that were in production in 1911. It's all over the Appalachian coal basin. Finding a way to incentivize treatment of that water, which is a major pollutant. It wipes out more stream miles than any other pollutant we have in the Appalachians. So just finding a way to incentivize that, to get people thinking about that as a resource rather than just a pollutant and a liability that has to be dealt with, does a couple things. One, it helps clean up streams because it brings money into that sector, because you can't extract the rare earths without actually cleaning up the acid mine drainage. So that it's a benefit in that regard. Secondly, in these coal communities where the acid mine drainage comes out of the old mine portals or refuse piles or whatever, you have infrastructure, you have a road network, you have transportation, you have a workforce, you have a lot of things already there that allow you to move into commercial operations relatively quickly.
Right now, researchers are fine-tuning the process to optimize the rare earth extraction. The end result will be a highly enriched rare earth oxide that can be further refined into rare earth metals.
What we really need to find out is how much it costs to process a ton of material through this kind of technology. And once we get those operating conditions under control, we understand what they are, then we can start designing the next stage, which is a field scale pilot or demonstration plant, or maybe even a commercial scale unit.
Dr. Zimkevich says they've done a survey of mines and AMD treatment sites in the northern and central Appalachian coal basins, and have determined they produce about 800 tons of rare earth elements with a value somewhere north of $190 million a year. So if this can be expanded to an industrial scale, this has a huge potential impact on the region's economy. For Environment Matters, I'm Brianna Hickman.
Thank you, Brianna. This second phase of the process is expected to be completed by this time next year. We'll keep you posted on the team's progress. The sounds of heavy equipment moving earth is not that unusual in the southern coal fields of West Virginia, but on a mountaintop in Mingo County, there's a new sound and a new machine that's turning reclaimed mine sites into farm fields. The DEP's Mike Huff has the details.
This thing's like a jet fighter cockpit.
This is no ordinary piece of farm equipment. Welcome aboard the SEPI Super Soil Stone Crusher. That's Nathan Hall, president of Reclaim Appalachia, at the controls of all this noise and vibration. And what he's doing is turning this into this. But first, a little background.
There are hundreds of thousands of acres of land throughout central Appalachia and West Virginia, and Kentucky that have been surface mined and reclaimed over the past 30 to 40 years. And really only a small fraction of that is in what I would consider active production of any type, really, especially in terms of really productive agriculture. And so it's been my mission for the past several years to find out what is the most effective and cost-effective way to take these many times very large landscapes and convert them into much more farmable lands.
Reclaimed surface mines tend to have very compacted and rocky soils with a lot of large stones close to the surface. Not ideal for large-scale agriculture.
And so if you were to try to go back to it with any type of typical tillage equipment like a rototiller or a disc or a chisel plow, you'll either break that equipment very quickly or it just won't even go in the ground at all.
Enter the stone crusher. It was built to take on the rocky soils of Europe and can pulverize rocks up to 16 to 20 inches in diameter. It's made by an Italian company, but if you're expecting Ferrari or Lamborghini speed, think again.
Even though you're only going 0.4 miles an hour, it's just constant work to kind of monitor the ground conditions and respond to them in time. I've always got to try to maintain as much work and depth as possible without bogging the machine down. As you can see, this is very uneven terrain after we've run the ripper across it.
Before the stone crusher does its thing, crews use a ripper attachment to break up the soil and bring the larger rocks to the surface. The ones that are too big for the stone crusher are shoved into windrows or broken up into more manageable sizes with an excavator and a jackhammer attachment. And then it's time to fire up the stone crusher and help speed up the geologic time scale.
In a 500,000 year process and do it in about 5 minutes. So if you think about it, it's really the same as just breaking down rocks from wind and rain and natural processes, which is how soil is made in the first place. We're just doing all that mechanically and very quickly.
This is the second trip to Coalfield Development Corporation's agroforestry test site at 22 Mine Road in Mingo County. The group used the stone crusher last November to condition a small test plot, about 1/5 of an acre, that was planted this spring with a variety of crops, cut flowers, vegetables, and berries, as proof of concept that land prepped like this could support a variety of plants. They also planted some cover crops that will be plowed back under to help introduce organic matter back into the soil.
Immediately after using the stone crusher, we're planting that into a mix of buckwheat and soybeans and sorghum sudan grass, and then we'll till that in, and then we'll replant in mid to late September with a mix of wheat and Austrian winter peas and vetch and things of that nature. So by doing that continuous cycling of cover crops as well as bringing in some organic matter, I think we can really quickly have soils that rival your high quality bottomland soils.
There's even potential options for grazing livestock, but the primary focus is high value crops.
If you go to any existing reclaimed mine site, you see blackberries galore and also wild raspberries. So to me that shows that these plants already do really well. These are kind of natural pioneers. Commercial blackberry and raspberry farming is quite profitable. So I think that's one of the really suitable types of high value crop production are the bramble fruits. Also grapes really like stony kind of semi-arid conditions. So I think viticulture is definitely a possibility in these lands. Lavender is kind of a Mediterranean plant that likes rocky kind of well-drained soils.
This summer's demonstration conditioned about 15 acres in about 100 hours of stone crusher operations. So the process does seem to be scalable to larger plots of land.
As we're entering this phase of kind of understanding that we are going to keep having coal mining in this region, but it may not ever be quite at the level that it had been previously, and also as we keep realizing that many of these reclaimed mine sites aren't very likely to be turned into a Walmart or a hospital or a golf course and whatnot. I think we're at a really good point in time to start thinking creatively about what really works on these sites, what is really scalable. And so that's really been my motivation, is figuring out A, what works physically on the landscape, what do we know that we can actually do from a physical standpoint, but then also what is going to be economically viable into the future.
In Mingo County, I'm Mike Huff for Environment Matters.
This summer's demonstration has generated interest from several parties looking to lease time with the machine. They say plans to purchase the Super Soil Stone Crusher are currently underway. A partnership between the Forest Service and the watershed group Friends of the Cheat is offering folks a chance to experience the waters of West Virginia in a whole new way. The DEP's Brianna Hickman joins us now with the details.
Jake, on a stream called Horseshoe Run in the Monongahela National Forest, folks are getting a fisheye view of an underwater world.
There you go, bud. One more. Ready? Push. Okay, I'm in. You over. Okay. I'm still.
First, the wetsuits.
Harold, do you know how to put these on?
And then getting fitted for a snorkel and a mask. And then it was off to the water, and a new perspective on aquatic life.
A lot of people just see a stream or a creek from the surface, from above. We're terrestrial creatures, so we're trying to introduce them to the aquatic world in a new way and to see what actually goes on under there. It's pretty surprising what you can see with a snorkel that you can't see from the shore.
Horseshoe Run is located inside a national forest in a sparsely populated part of the state, and because of those protections, it's in pristine condition, unlike many other streams in the state that suffer from problems like acid mine drainage, erosion and sediment problems, and high levels of bacteria caused by failing septic systems or inadequate wastewater treatment.
So what we're trying to do is show the public what a healthy watershed should look like. And so when they're out recreating and maybe seeing some of these impaired watersheds, they can see what we're striving towards and maybe some of the components that are lacking from those systems that have been impaired.
But besides the educational opportunities and raising awareness, this day was also about having fun.
It was awesome!
Tell me some of the stuff you saw.
I saw some minnows and some big fish.
I think a lot of people they're not really aware of how unique this area is and how unique these species are. So what we're trying to do is immerse them into that world to come and enjoy and learn a little bit more about the awesome aquatic ecology that we have here on the Monongahela National Forest and also within the Cheat River watershed.
The snorkeling events are open to the public and take place at various locations within the Cheat watershed during the late summer, when the water flowing out of the mountains is its warmest, relatively speaking.
It was a little cold, but I liked it a lot.
The Forest Service has been hosting these snorkeling excursions for the last 4 summers and say they've been growing in popularity. In fact, the day we were there, the group that had just finished up were asking about when the next snorkeling event was being held. This was the first year they partnered with Friends of the Cheat, and they hope to expand the program next summer. If you'd like to find out more, check out their website at cheat.org. For Environment Matters, I'm Brianna Hickman.
Thank you, Brianna. That looked like fun. We leave you now deep in the forest along the Allegheny Trail in Preston County. On behalf of all of us here at the West Virginia Department of Environmental Protection, thanks for watching. We'll see you next time.
More than 800 people with one mission, promoting a healthy environment. We are the West Virginia Department of Environmental Protection.